Here's a little help for question 12E from section 3.1 in the 8.2 section from the textbook that I have linked there. So when you're taking a look at the original equation that they gave you, there's just some information that I kind of drew for you in the top right here. So here's our standard equation. What we know is that the first vector point that we have here is a known point. The next two vectors that were going to be included, so the one after the t and the one after the parameter s, are vectors that are parallel to the plane but non-parallel to each other. So if we're thinking about 12E in particular, it says you need to find an equation for each plane, and in this case it needs to contain the x-axis and be parallel to vector A, which is 4, 1, negative 3. The solution that they gave you is shown below. I just copied it down for you so that I could explain this. Now it is an answers may vary kind of solution, so that means that you could have got different answers. I'm just going to talk about this one and maybe what some different answers might look like. So the first thing that they did was they needed to include a known point. So we need to include any known point, and in this case it needs to be on the x-axis. So we know that this is the x, this is the y, this is the z. So you could include any number here. Okay, so it could be a 1, it could be a 7, as long as these, the y and the z, were 0, any point will work there. Now, the next vector that they included is the 4, 1, negative 3. Now, that is the vector that we needed to be parallel to, so that is why that one is there. And when we're thinking about our third vector right here, in this case it's a 1 because we know that we need to have this x and this x match this x. So if you wanted to write another one, and you wanted to include, say, I don't know, a 5 here, okay? This vector will remain the same. And in order for us to include a third vector here so that we get a 4 overall, this would need to be a negative 1. For question 8a from part 8.3 from the textbook, I'm just going to go through A and you can take a look at the rest on your own, because I think after taking a look at 12E and 8A, I think maybe you'll have a better understanding because this is a very similar type of question. So the question itself says you need to find the equation of the plane that is perpendicular to the line given here. Let me just change colors here. And includes this point right here. So this is the solution in the back of the book. Again, its answers may vary, so you could have many different solutions. One thing that won't change is this point right here. We know that our plane needs to include that point, so that needs to stay no matter what. The two things that can change are the two vectors right here. We know that these vectors need to be parallel to the plane. Now, our plane needs to be perpendicular to the line given above. We know that if we want something to be perpendicular, we need to make the dot product 0, or the dot product will be 0. There we go, I can't write there. So, we need to come up with two vectors that give us a dot product of 0 when we're taking a look at this direction in this first line. So 3, 5, negative 3. The two vectors that they chose were 1, 0, 1. So if you do from this vector, taking a look at this vector, the dot product, we have 1 times 3 is 3, 0 times 5 is 0, and 1 times negative 3 is a negative 3, so the dot product will be 0. And when I do the dot product between this second vector and this vector again, I have 0 times 3 is 0, 3 times 5 is 15, and 5 times negative 3 is negative 15, so again, we will have a dot product of 0. So as long as when you do the dot product of this first direction vector and this second direction vector, as long as that dot product is 0, your answer will be correct. When I take a look at 10b in 8.3 from the textbook, it says determine if the planes in each pair are parallel, perpendicular, or neither. So what we know is that if something is going to be perpendicular, because the answer to this one was perpendicular, dot products must be 0. So when I take a look at this first equation right here, I get the normal vector 5, -6, 2. The way that you can think about this is this can be rewritten to go on this side. It's not a big deal, or you can just take a look at your x, your y, your z components. And when I take a look at the second equation right here, I get a normal of 2, -5, -20. So what I need to do is I need to calculate the dot product. I'll just call this one A and this one B. So I've got A dot B is equal to 5 times 2, -6 times -5, and 2 times -20. 10 plus 30 is 40, minus 40 is 0. Since the dot product of my normal vectors is 0, that means that I do know that this is perpendicular. I do just want to add quickly that if you were to determine if these ones were parallel, what you would need to decide is if these two vectors that I have right here, I can't even write, I don't know what's going on here, sorry. If these two vectors that I had right here were scalar multiples of each other, then they would be parallel. So if these two vectors are scalar multiples, parallel. If the dot product is 0, they're perpendicular. And if neither of those things are true, then the answer would be neither. That will help you get all of the rest of the solutions, even though you only specifically asked me about 10b. I just kind of wanted to go over the 3 options for this question. All right, so for question 10b, you're absolutely, I think, on the right track. Your normal vectors were perfect, so 2, 0, 3 and -1, 6, 3. That is great. We do know that if the dot product was 0, these would be perpendicular. We know that the dot product is not 0, it's not perpendicular, so we do have to use a different formula. The different formula can be rewritten in a whole bunch of different ways. I'm just going to rewrite it like this. So cos of theta is equal to, and I'm just going to use my n's because that's what I called them here. So normal 1 dot normal 2 divided by the magnitude of normal 1 times the magnitude of normal 2. So if I go and do the dot product of normal 1 and normal 2, I have 2 times -1, which is -2, plus, I'm just going to do it up here, I guess, -2 plus 0 times 6 is 0, plus 3 times 3 is 9. So I'm going to get a normal, or a dot product, sorry, of 7. Now, when I calculate the length of each of these, I'm just going to go ahead and I'm going to erase this so that we can, I can show you what I'm doing as I go. So the length of this is equal to the square root of 2 squared, which is 4, plus 0 squared, plus 3 squared. So I have the square root of 13. And then the length of this one, the square root of -1 squared, which is 1, plus 36. So we have 37 plus 9. So we have a 46. So here I have a root 13 and a root 46. Now, I'm running out of room, and I'm really sorry. I should have thought this through a little bit better. I am just going to simplify this a little bit more. It seems kind of the opposite of what we normally do, but I'm just going to change this to be 13 times 46, which is root 598. So I have cos of theta is equal to 7 over root 598. If I want to find that angle, I need to do cos inverse of that. And when I do that, I think that, I'm assuming this is what you did. Maybe you were off by a little bit, but if I do 7 divided by the square root of 598, and I take the inverse cos of that, I do get 73.36, so 73.4 degrees. Let me go back. I think you said 72.7, so I don't know if you made a little mistake in there or something. I did notice that the textbook does say, I don't know, let me just go back here. Sorry, 1 second. The textbook does say that the answer is 101.2, and I'm going to go ahead and say that that is wrong. I went through this twice just because the calculations that I got were different, and I am very 100% confident that they are wrong. So please just go through here. You're definitely on the right track. You're doing really good, and you should be really proud.